So hello everyone, the YODAS team is very proud to present to you our stage 2 solution regarding the optimization of soft mobility drop-off points in the city of Porto. We think that these solutions are very important for the sustainability, however we also think that it's very important to think and integrate them with the already existing infrastructures. So with this in mind, we decided to think about the main factors that contribute to the increasing usage of soft mobility, and we thought about the public transports, the flow of people, and the points of interest in the city. Using these three main factors, we decided to create a probability of usage score for each one of the zones in the city, and then with this create an optimal distribution of scooter drop-offs that can maximize the usage by the population. These zones that I'm talking about are basically little squares that we created, splitting the city into a grid of more than 7,000 little squares, and in each one of these little squares we can attribute several features, several characteristics that are then used to create a score per each one of the squares. These features are various. They are all related with the three main factors that I talked about in the beginning, and here we have an example of the distance to the nearest subway station. We use this set of 13 features in total as input to a random forest classifier to predict if a zone, given the set of features, has a high or low number of scooter trips started there. Although the model obtained a very decent performance, the main goal was to look at the feature importance coefficients and to know what are the features that impact more. And then we use these coefficients to create the final score that you can see here in the distribution. For example, the downtown of the city has a very high number of zones with high scores, which is extremely expected for anyone that lives in the city. This final score, was then the main variable to maximize in our optimization algorithm that ensured, using these two restrictions regarding a radius and the number of drop-offs per parish, and with this it ensured that the new drop-offs are distributed evenly, more or less, throughout the entire city, so everyone can get a scooter relatively close to any place. So with our final product and solution, we expect to have an increase, of course, in the number of scooter trips. It's a solution that it's integrated with the public transports, and it's mindful about the resident population, not only about the tourists, but most importantly of all, our solution and our product is adaptable, it's dynamic, and we strongly suggest the decision makers to run for example, our classification model with newly updated scooter trip data to catch the feature importance and the impact of each one of the features throughout the entire year, because we know there's a seasonality and there's temporal aspects in this data. So we strongly suggest you to run this several times and then use, for example, our demo application to manipulate and change the different scores and different impacts of each one of these features to create new updated final scores that can then be used to create new and updated distribution of drop-off zones that maximize the usage by the population throughout the entire year. And thank you very much, that's it.